Hi, in this video we're going to take a look at the last two problems. They'll deal with kind of all the different basic probability stuff we've done together. And there's some really good problems that hopefully make a lot of sense to you. All right, there's a 15% chance you throw a dart and hit a balloon taped to the wall. Now, what does that 15% chance mean? Because that's got an important part of understanding understanding the definition. Remember, that means in the long run, not after 10 throws, not after 100 throws, after many, many, many throws, you feel confident that in the long run, after many, many, many throws, you'll break the balloon 15% of the time with that dart. All right, if there are 3 balloons, you try to throw a dart at each of them. Now, I have to assume that I'm not going to get better or get worse. I'm not going to feeling better, like, oh, I popped one. All right, now I'm feeling good. Now the chance of me popping the next one goes up. Oh, now I hit 2 in a row. No, I have to assume independence. That means that if I make or break the first balloon, that will have no impact if I make or break the second balloon. It'll stay 15%. It's not going to go up if I start doing good. It's not going to go down if I start doing bad. You got to assume independence here. All right, what's the probability? You break all 3. Doesn't get easier because there's only one way this can happen. Break, break, break. Win, win, win. Hit the balloon, hit the balloon, hit the balloon. That's 0.15 to the third. 0.15 times 0.15 times 0.15. It happens all 3 times. Probability, 0.003375. Use calculator if you don't believe me. Pretty unlikely. That is approximately a 0.34% chance that you are going to break all 3 balloons. So if that happened, I'd be like, whoa, are you, think about it. If that happened, I would be shocked. I mean, that is extremely low. And I would say, wait a minute, are you better at this game than you think? Because the only way you could break all 3 in a row is if you're much better than 15%. Because if it is 15%, breaking all 3 in a row, not gonna happen. All right, you break 1. Now this is where we gotta start thinking, okay, got different situations. I break 1. So that could be break, not break, not break, or not break, break, not break, or not break, not break, break. There are 3 distinctly different scenarios where I only break 1 balloon. So again, if you think about mathematically, we've had this happen several times now. Mathematically, these probabilities are all the same. Mathematically, I need a single break. Who cares where it is? First, middle, last. Doesn't matter. And then I need 2 not breaks. Well, first off, I'm already wrong because I wrote a 13%. That's not right. It's 15%. Sorry about that. I make mistakes all the time. All right, so if there's a 15% chance I break, that means there's an 85% chance I don't break, and I need that to happen twice. Again, all 3 of these, although they're distinguishably different, mathematically, all 3 of them have 2 not breaks, 0.85 times 0.85, and a single break, 0.15. So I'm going to just get that answer and multiply it by 3 because I got to understand there's 3 distinctly ways to do it. Again, I could do the math 1 time, 2nd time, 3rd time, add them together, or I could just do the math once and times it by 3. Makes more sense to do it once. So 3 times 0.15 times 0.85 squared is 0.325. A couple extra decimals there, but I'm okay with 3 decimals, 0.325. So that would be very likely. That would not be weird at all if I broke 1 of the 3 balloons. All right, you break at least 1. Okay, be careful with the word at least. At least 1 means 1 or more. So this means I break 1 balloon. Now, we just found the probability of breaking 1 balloon, 0.325. This means I break 2 balloons. I haven't found that probability yet. Or I break all 3 balloons. Well, okay, I have found the probability I break all 3 balloons, 0.34. Whoa. Gosh. It's 0.34%. It's 0.003375 as a decimal. That's very important if I would have made that mistake. All right, so at least 1 means I break 1 or more. So that's 1. I already got that probability down pat. I already answered that. 2. Now we got to quickly do 2. So let me just come to the side here. 2 balloons could look like this. Break, break, not break. Break, not break, break. Not break, break, break. Again, same thing we just went through. All 3 of these scenarios are distinctly different, but they all have 2 breaks, so 0.15 times 0.15, 0.15 squared, and 1 not break, so 0.85. But there are 3 of these different scenarios. So I'm going to go to my calculator. 3 times 0.15 squared times 0.85 is 0.0574. 0.0574. So to find the probability you break at least one, I'm going to add up the probability you break one or two or three, because at least one means one or more. And I can get my answer. All right, great. I can do all that. That's not going to be a problem. Do it. Simple, right? Simple, simple, simple. But there's actually an easier way. Now, listen, that works. If you understand that, do it. Get your answer. You'll be done. Add them together. You're done. But there's another way, right? Think about the only scenario that's not listed here. That would be don't break any. That would be 0.85 to the third. There's only one way that could happen. No, no, no. No break, no break, no break. There's only one way that can happen. 0.85, 0.85, 0.85. No other scenario. So, listen. The opposite of at least one would be none. So, think about that, right? At least one would be one break, two breaks, or all three break. The opposite of that would be none break. So, another way I can answer this question is to find the probability that none of them break. 0.85 to the third, and then do 1 minus that. So basically get rid of that. Like 100%, that's the one. Something has to happen. When you throw 3 balloons, you're either going to break 1, 2, 3, or none. So something has to happen. So 100%, something's going to happen. Subtract away the no breaks, and I'll be left with at least one, right? That should make sense. Again, it'll get you the same answer. I don't care how you get your answer, but if you're looking to get it done a little faster, say, all right, at least one is 1, 2, or 3. It does not mean 0. So let's find the probability that you break 0, 0.85 to the third. It's like 0.614. And then do 1 minus that answer, and you're left with 0.386. And again, this is approximations. I'm rounding 0.386. So that's the probability. Again, add the 3 together. Break 1 or 2 or 3. Add them together, you're going to get a very similar answer. Might be a little bit off because of decimals, but very similar answer. Or a little bit of a faster way is just say, well, wait a minute. At least one, the opposite of at least one is none. So why don't we find the probability I break none and then do 1 minus it. Hopefully that makes sense. That's a really good strategy, especially to speed things up. Last question. Here we go. A 911 call center, there's a 31% chance a call requires an ambulance to be sent. Explain what a 31% probability of an ambulance means. All right, I'm not going to write it out. I'm going to say it. You could write it. What does 31% probability mean? It's the relative frequency in the long run. It's the percentage of times that an ambulance would get called to the scene in the long run. So after many calls, not after 100, don't tell me 31 out of 100. It's after many calls. This 911 center's had thousands of calls. And after all those calls, they know that about 31% of those calls in the long run are going to require an ambulance to be sent. All right. Hopefully you can write that down. B, what is the probability the first call needing an ambulance is the 5th call of the day? So this is very, very specific. The first call needing an ambulance is the 5th call of the day. So 1, 2, 3, 4, 5. There it is. The 5th call needed an ambulance, 31%. So what happened on the first 4 calls? Well, that means they did not need an ambulance. Well, if there's a 31% chance that you do not need an ambulance, then there's a 69% chance that you don't need an ambulance, right? 31% chance you need an ambulance, 69% chance you don't need an ambulance. It's just the opposite. So on the first call, didn't need an ambulance. Second call, didn't need an ambulance. Third call, didn't need an ambulance. Fourth call, didn't need an ambulance. And on the 5th call was my first call needing an ambulance. So again, this is extremely specific because it cannot happen any other way. If I put the 0.31 anywhere else, then that's not what the question says. I need it to happen on the 5th call of the day. So this would be 0.69 to the 4th, 4 straight non-ambulance calls, and then that 5th call requires an ambulance. 0.69 raised to the 4th times 0.31 is 0.070. Again, there's some more decimals there, but I rounded. Actually, let me give one more decimal. 0.0703. Again, 7% chance. That is not weird at all. That is not unlikely at all. That would not be weird for the 5th call to need that first ambulance. All right. Oh boy. What is the probability the first 10 calls all need an ambulance? The first 10 calls all need an ambulance. Well, there's only one way that can happen. Needs an ambulance, 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 needs an ambulance. All 10 need an ambulance. That can't happen any other way. Obviously, I'm going to speed that up by putting 0.31 to the 10th. All 10 calls in a row all need an ambulance. 0.31 raised to 10th. Oh, get ready for this. Hopefully you're using your calculator so you could see this. There is an e to the negative 6. So I got to move the decimal 6 times. So it's going to be 0.0000820 if you round it correctly. 820. It's like 8196, but that would round to 820. Okay. Would this be unlikely? Yes, this would be very, very unlikely. This should not happen. In fact, I would be like, oh my God, what's going on? What if this did happen? My guess is there was a major accident. Maybe there was an earthquake. This is not a normal day. This is not a random day. For there to be 10 calls in a row that all need an ambulance, maybe there was an earthquake, maybe there's a major accident on a freeway, maybe there was a house fire. I mean, something had to have happened. That is very much out of the ordinary, because if for this to just happen on a random day, very unlikely. In fact, I would use the word dang near impossible. So if this did happen, there's got to be a very, very good explanation for it. All right, guys, hopefully that makes sense. That's the end of this unit, or on part 1 on basic probability. A lot of really good math there. Hope you enjoyed it. Hope you're going to start slowly getting good at this stuff, because I absolutely love it. All right, see you later.